Unit 1 Study Guide. Number 1. The circumference of the Earth's moon is about 1,091,500,000 centimeters. Write this number in scientific notation. I'm going to underline scientific notation. That's how the answer needs to be presented. I'm going to take this number, write it out to the side here. 1,091,500,000. And I'm going to look for the decimal. The decimal, if you don't see it, is at the very end. What I need to do is move that decimal to where there's one digit to the left. So I'm going to move it all the way over to where it's right here. That's going to give me 1.091. Notice I'm dropping the commas, and I'm also dropping the zeros after the last digit of 5. If there was another number, then I would include it. Like I needed this 0, it's very important. So my final answer will be 1.0915. But how many places did I move that? And how many places I moved it is going to be times 10. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times. And that's going to be a positive 9. What helps me to remember is that was a really big number, so it's going to give me a positive exponent. And of course, that's in centimeters. Number 2, which equations are true? Choose all that apply. 15 to the 0 power. Anything to the 0 power is 1. So that one's not right. Number 2, part B. When I'm multiplying powers, I need to add the exponents. So 8 to the 3rd times 8 to the 6th, I need to add those up to give me 3 plus 6, which gives me 8 to the 9th. That one's true. Here, if you notice, I've got 5 to the 2nd power, and then I have 5 to the negative 3rd power. Well, if I move this to the bottom of the fraction, it will be negative, but it's not going to change the negative, so that one's not correct. D, if I have a power raised to another power, then I'm going to be multiplying. So there, that would give me 6 to the 5th power times 3. So 5 times 3 is going to give me 6 to the 15th power. So that is true. E, when they're stacked, you subtract. Start at the top. So we will have 7 minus 9. 7 minus 9 gives me a negative 2 for my new exponent. So that one's correct. Notice the work that I'm showing. You'll need to show work on your exam. Number 3, the virus that causes the flu has a width of 130 nanometers. A nanometer is about this amount. It's very small. Write the width of the flu virus in scientific notation. So this is 1 nanometer. We need to multiply it by 130. Since we've been talking about multiplying powers with the same base, let's change both of these into scientific notation. So 130 as nanometers would be 1.3. So my understood decimal is at the end. And I'm going to move it to give me 1.3. And I moved it over. Let's count. 1, 2, Then I'm going to take this very small number, which is the length of the nanometer. How many zeros is that? Let's count the zeros between the decimal. 1, 2, 3, 4, 5, 6, 7, 8. And so this is a very small number, but I can still change it into scientific notation. Again, I need one digit to the left of the decimal, so I'm going to have to put that new decimal over here. You can have 1.0, or you could just write it as 1. But how many places did we move it? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, since this was a small number and I moved my decimal to the right, it is -9. So now what I'm going to do is I'm going to multiply these two numbers together. And all I have to do is multiply the numbers out in front, which is 1.3 times 1, which gives us 1.3. And remember, when you have the same base, you add your exponents. So 2 plus -9 gives us 1.3 times 10 to the -7 power. And there's our length in scientific notation. Notice the directions wanted that in scientific notation. Number 4, the width of a red blood cell is approximately 8 micrometers, which is 8 times 10 to the -6 meter. Give your answer in scientific notation. So in the last problem, we've been talking about taking scientific notation and multiplying the two scientific notation numbers together. So what we're going to do is we're going to multiply 8 and 7.2 together. 7.2 times 8. 8 times 2 gives me 16. Carry the 1. 8 times 7, 56 plus 1, 57. Go over one decimal place. And then what we're going to do is we are going to add our exponents of 10. So that would be times 10 be -6 plus 5. Notice this is not quite in scientific notation because that decimal really needs to be over here. -6 plus 5 gives me -1. Now let's fix this. That decimal needs to be over here. Remember I said one digit to the left. So 5.76 times 10. Now whenever I move the decimal, it's going to change my exponents. Notice this went from 57.6 to a smaller number, 5.76. So if this number gets smaller, this number gets bigger. Well, I moved it over 1. Then this is going to get bigger by 1, and that's actually going to go to become 0. They want it in scientific notation, so it would be 5.76 times 10 to the 0 power, which we really wouldn't leave it like that, but the directions did say give your answer in scientific notation. Part B is a little tricky. If a grain of salt is 0.5 millimeters wide, how many red blood cells could fit across 1 grain of salt? Then they give you this hint. 1 millimeter is 1 times 10 to the -3 meters. Well, we need to first figure out half. So what we're going to do is we're going to take that 1 that equals 1 times 10 to the -3, and we're going to convert that to a half. So remember that this 0.5 needs to be moved over to make it into the correct scientific notation. So that's going to become a 5. So I'm going to make it bigger. Notice it's going from 0.5 to 5. So if this gets bigger, this gets smaller. I just moved it over one spot, so it's going to get smaller by 1. So this is the length of salt. We already know the length of one red blood cell up there at the beginning. We want to know how many times this red blood cell will go into this grain of salt. So we're going to divide. So how we divide scientific notation is you're going to divide the numbers out in front. So 5 actually 8 into 5. The bottom goes into the top. 8 doesn't go into 5. So we're going to try 50. 8 goes into 50 6 times. 6 times 8 is 48. Bring down another 0. 8 goes into 20 2 times. Bring down another 0. 8 goes into 40 5 times. So now I've divided that to give me 0.625. Divide the numbers out in front, and then I need to subtract my exponents. So -4, always start at the top, minus -6. Remember, when they're stacked, you subtract. -4, two negatives make a positive, so it's -4 plus 6. Gives me a positive 2. Still not my final answer, because this decimal is in the wrong place for scientific notation. We're going to move it over one more time to give us 6.25. I went from a smaller number to a bigger number, so this has to get smaller. So that's how many times a red blood cell can go into 1 grain of salt. Number 5, which is an equivalent fraction for 0.25 repeating? So what we're going to do is we're going to create an equation. I'm going to say that x equals 0.265 repeating. And I'm going to solve this equation. What that solving the equation do will give me one of these fractions that are the same value as this repeating decimal. Now if you notice, this last digit is in the thousandths place. So I'm going to multiply both sides by 1,000. So that'll give me 1,000x. On the other side, we've been talking about scientific notation and moving the decimal. If I multiply by 1,000, then that means this decimal goes at the end. So I'll have 265. And what goes after the decimal? Well, these numbers keep repeating, so it'll be 265 repeating. The next thing that I want to do is I want to get rid of this repeating portion. So I'm going to subtract this repeating portion. Now notice we started off with x equals the repeating portion, 0.265. So I'm going to subtract x from both sides. X equals 0.265 repeating. So I'm going to subtract that from both sides. 1,000x minus x gives me 999 x's. And all that I'm doing here is taking off the repeating portion to give me 265. At this point, you should be familiar with solving equations, and we're going to divide by the coefficient, which is 999. Coefficients cancel out, and my final answer is 265 divided by 999, which is C. Last year, number 6, a popular mobile app was downloaded 2.47 times 10 to the 8 times. Write a number of times the app was downloaded in standard form. So this is a really simple question. All you have to do is move the decimal over. You have 2.47 times 10 to the 8th. Notice the 8 is positive, so it's going to turn into a big number. That means we have to move this decimal to the right 8 places. So, if I go 1, 2, I need 6 more zeros. 2, 4, 7, 1, 2, 3, 4, 5, 6. Now I'm not going to put the decimal at the end. We all understand it's at the end. However, I am going to insert the commas in standard form. And we could check it. Here's my understood decimal. 1, 2, 3, 4, 5, 6, 7, 8. And that's where the decimal was. So that's standard form. So 247 million is in standard form. Number 7, Mateo is making a wooden cube to hold his sister's jewelry. The volume of the cube is 343 cubic inches cubed. What is the length of one side of the jewelry box? So the volume formula is side cubed. And what we need is just one of those sides. So they give us the volume, 343. And what we need to do is take the cubed root of both sides and figure out, remember the cubed root and the exponent of 3 cancel each other out, what one of those sides are. So you have to think, what could I multiply 3 times to give me 343? Well, it's 7. 7 times 7 gives me 49. 49 times 7 gives me 343. So 7 is my magic number, so that would be 7 inches. Number 8, determine if the statements are correct. Choose yes or no for each statement. The standard form of 4.15 times 10 to the 6th is the following: 415 million. Let's check. If I took 4.15 and converted that into standard notation, that 6 means it's positive, so I would move this decimal 6 places to the right. That would be 1, that would be 2. I would need 4 more zeros. Looks like I have 6 zeros. So no, that's incorrect. The standard form of 3.1 times 10 to the negative 3 is 0.031. Let's check. 3.1 times 10 to the negative 3. Negative means I'm moving the decimal left to become a smaller number. So if I move this over 1 place, I would still need 2 more places to go. So that means 2 zeros between the decimal and the 3. This 0 is just for decoration out in front. Let's come over here. I see the same number, so yes. Part C, the standard form of 9.15 times 10 to the 11th is the following. Let's check. If I have 9.15 times 10 to the 11th, let's see, It's a positive exponent, so that means I'm going right. That'll give me 1, 2. I'm going to need 9 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it looks like we have that. So that is yes. Number 9. Consider the expression 5.9 times 10 to the 6th and 3.2 times 10 to the 4th. Find the difference. When you're finding the difference, it's a lot like fractions. You want to have a common denominator, but here we don't have denominators. We need to have the same base. Same base of 10. So notice I have an exponent of 4 and I have an exponent of 6. What I want to do is make the small exponent like the big exponent. So I want to make this 4 into a 6. Now remember on the previous problems, if this gets bigger, notice it got bigger by 2, this number out in front is going to get smaller by 2. So that decimal is going to move 2 places to the left. So that's 1, and I'm going to need a 0 between the decimal and the 3. Remember, this 0 out in front is just for decoration. So that was 1, 2, minus 5.9 times 10 to the 6th. I'm not going to change this other number. Now I have the same base 10. Now I just simply subtract the numbers. 5.9 minus 0.032. Always line up your decimals when you're adding or subtracting. Make that a 10. That gives me an 8. Gonna have to keep borrowing here. Come back over here. I've got 1 digit to the left of the decimal, and I'm going to keep that same exponent. So 5.868 times 10 to the 6 is the difference. Part B wants us to find the product. So to find the product, you're going to multiply these numbers out in front. 5.9 times 3.2. 2 times 9, 18. 10, 11. 0 is a placeholder. 3 times 9, 27. 3 times 5, 15, plus 2. Add those up, 8, 8, 8, and 1. I've got a total of 2 decimal places. And remember, when we were multiplying powers, we added our exponents. So that would be 6 plus 4, which gives us 10. Now look at my answer. Not quite in scientific notation. I'm going to move that over 1 spot to give me 1.888. That got smaller. This gets bigger. So the product is 1.88 times 10 to 11. Number 10. 9.2 times 10 to the 8 is how many times the value of 2.3 times 10 to the 2nd power? So what we're going to do is we're going to divide. We're going to put our biggest number on top, 9.2 times 10 to the 8. I know that it's bigger based on the exponent. Divided by 2.3 times 10 to the 2nd power. So remember what we've talked about. We're going to divide the numbers out in front. 2.3 divided into 9.2. Move those decimal places over. So how many times will 23 go into 92? That's actually 4 times. 4 times 23 gives us 92. So that's even. So I've got 4, and you could put 4.0 or just 4 times 10. And remember, we are going to subtract our exponents. When they're stacked, we subtract. So 8 minus 2 gives us 6. So your answer should be B. Number 11. Taylor multiplied 8.25 times 10 to the 4th and 0.4 times 10 to the 4th and got 8.65 times 10 to the 4th. Explain Taylor's mistake and give the correct answer. Well, let's just multiply it ourselves. If you notice, this is not incorrect scientific notation. It really doesn't matter at this point. What matters is the final answers in scientific notation. So let's multiply our numbers out in front. They did say multiply. So 8.25 times 0.4. 4 times 5 is 20. 4 times 2 is 8 plus 2, 10. 4 times 8 is 32. Plus 1 is 33. 3 decimal places is 3.3. And then we are going to add our exponents. So 3.3 times 4 and 4 would give us 8. Wow, Taylor was way off. So we got 3.3 times 10 to the 8th. That's the correct answer. They did say give the correct answer. What do you think he did wrong here? Maybe he added instead of multiplied? And that would give us 8.65. So maybe Taylor added instead of multiplying there. Number 12, which numbers are irrational? Irrational meaning these numbers cannot be written as a fraction. Part A, I look at the square root of 26. And when you're taking the square roots of numbers, you have to think about your perfect squares. One times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and so forth. So if you notice, 26 is not a perfect square. So when I take the square root of a number that is not a perfect square, it will be irrational. So the square root of 26 will be irrational. Part B, repeating fraction. Well, I just showed you how to convert any repeating decimal into a fraction. So this is rational. 144, if I kept going here, 11 times 11 is 121, 169. And then I just totally skipped over 12, which is actually 144. So that is also a perfect square because 12 times 12 gives us 144. Part D, I've got a number here that continues, but there's no repeating symbol, so we don't really know what the pattern is. So this is a prime example of irrational numbers. I cannot convert this into a fraction. Now, E is already a fraction, so anything that's a fraction is rational. So I don't really know why I circled that, because we are looking for irrational numbers. Irrational. And those three that I have a check mark by are rational. 13. A blockbuster movie makes about $247 million in the United States during the open weekend. That same weekend, another movie opens, but only makes $5,200. Write each dollar amount in scientific notation. All right, let's take this first one here. Remember scientific notation, we have to have one digit to the left of the decimal. 2.47 times 10. And how many places did we move it? 1, 2, 3, 4, 5, 6, 7, 8. 8 places. And then the other movie, 5.2. Don't need all those zeros. And let's move that decimal over. 1, 2, 3, 4, 5, 6. Both of them are in scientific notation. Part B, what is the combined revenue? So combined revenue means that we are going to be adding them up. So remember that when we add them up, we need to make the smallest power like the big power. Let's come over here. 2.47 times 10 to the 8th plus 5.2 times 10 to the 6th. So I'm going to make that 10 to the 6th like the 10 to the 8th. It went up 2. This needs to go down 2. So that means I'm moving it to the left to make this number smaller. So if I move it over 1, that means I need one more 0. The first number I'm not changing since it already has a power of 8. Remember that we're adding. So 2.47 plus, line your decimals up, 7 plus 5 gives you 12, carry the 1, 5, line the decimal up, and keep the same power. So we've got 2.522 times 10 to the 8th. I've got one digit to the left of the decimal, so that is in the correct scientific notation. Part C, how much more did the blockbuster movie make? Write your answer in scientific notation. How much more? So that means we need to subtract. Now, if I take what I just did and keep it, because whether you're adding or subtracting, you needed to convert the smallest into the biggest. But now I'm just going to subtract. So I'm going to keep that 0.052 times 10 to the 8th. And I'm going to subtract the numbers. 2.47 minus, still got to line up your decimals, 0.52. But now that's a 10, make that an 8, I borrowed, make that a 1, a 4, and a 2 times 10 to the 8th. And there we have it.